All right, let's do it. The Daily Space Weather coming at you with a steady solar uptick. Significant sunspot growth happening in the southern hemisphere. Also a little bit in the north. We'll cover it and lots more tonight at the Smash News Network. Least busted name in news. Let us know in the comments if you like the new time slot. First thing we're looking at is the past 24 hours from the Solar Dynamics Observatory. The house favorite wavelength is 171 angstroms, one of the many species of ionized iron. This one highlights the lower corona, the quiet corona. It's also the coolest of all of the AIA wavelengths. Here's a little closer view, the equatorial zoom, and you might note that sunspot growth right in the Earth-facing zone there in the southern hemisphere, a little bit of growth in the northern hemisphere, and also a couple of new active regions rising. So the likelihood of large solar flares rising as well. We could see one right on the limb, or we could see one right in the center of solar disk, especially in the southern hemisphere at that new sunspot group. There's that rising region in the northeast. And let's don't forget this rising region in the southeast. You'll see this brighten up right at the end of this 24-hour video. And let's talk about the channel. So if you haven't pressed the like button, please do. The video cannot continue until you press like. If we do not see 100 likes by the time I am done on this screen, we'll have to shut the video down and leave you to go get your space weather content and solar imagery elsewhere, which would be tragic. So press the like button, lest thy soul be cast into an ever-deepening and darkening abyss of debauchery, delusion, and doomsday myths. Hopefully you haven't joined a cult. By the way, we aren't planning on starting those, even if we get 10,000 likes. Still not going to start a cult. So press like, press share, press comment, tell your friends and foes, yada, yada, yada. Explore the links in the description. Help us out with clicks if you're unable or unwilling to open your cobweb-encrusted wallet. And have I requested that you press the like button yet? I seem to remember saying something like that, so press like, do it now. And we won't have to trace your IP address and your silver cord to your location so that we can cast thy soul into the river Styx. All right, now that I got that out of my system, you can also help out the channel by clicking links. So check out smashomash.com if you haven't. And welcome to the Neo Renaissance. We created a massive web ring back in 2019 for people just like you. However, it's on you to utilize it. So hit us up on social media. You'll find exclusive content all over the internet at Smashomash, thanks to all of our subscribers, our new YouTube subscribers, our old YouTube subscribers, and the Smash team. Thanks to Smash staff. Give her a raise by clicking our links in the description below this video. The following are paid endorsements. So first of all, you can find some stuff at our Amazon shop, amazon.com/shop/smashomash, whether it's eclipse glasses, electromagnetic radiation reflecting headwear. What about an infrared camera? How about battery backups? What about supplements? Save a bundle on bulk spices at our Amazon shop. Amazon.com/shop/smashomash is one of our paid endorsements. Here's another paid endorsement. Hemp Lucid. You can find a link to our Hemp Lucid storefront as well below the video. So click on that. Save some dough on mushroom gummies. Save even more dough on stress, sleep, and immune stacks. Save the most dough on the full stack package, which includes the stress, sleep, and immune all together. Save about $70 there. And good news, the lip balm is back in stock. They make great gifts. Perhaps do some early holiday shopping for CBDs and the like. Cordyceps mushrooms, lion's mane mushrooms, CBN, and all kinds of other products there from Hemp Lucid. Another paid endorsement is today's featured product, which is our bestseller, yes. And please, folks, no matter how bad things appear, don't pole vault the caldera. Our finest days lie ahead. If you're going through hell, keep going. Don't pole vault the caldera. If you're going on a volcanic vacation, leave the vault pole at home. Help get our channel out there. It's got the YouTube URL as well as the homepage, smashomash.com at the bottom. This public service message brought to you at massive personal risk and expense by Smash Staff and I. Again, it is the best seller at the merch shop. Links to the Redbubble shop in the description as well. 36 other designs available also on dozens of products. And let's get back to space. One more thing. The best way to support the channel is by becoming a member of the Smash Team. SmashOmash.com/Smash Team. It's our own subscription services site. We launched our own because we needed additional capabilities. So we've got them. You want additional content? That's where to get it. SmashOmash.com/Smash Team. The best value is the gold annual paid-up subscription. It includes complimentary merch. There's also a gold monthly subscription, a silver monthly subscription, and a bronze monthly subscription, which will cost you $0 per month. You'll get emails that will remind you about videos like this one. And let's get to the solar imagery. So here is the SDO continuum, and you can see significant growth of that sunspot group in the south, also a little bit of growth in the north. So yeah, also 2 new active regions there, likely rising over the eastern limb. Here's the colorized magnetogram for that same period of time. That is October 29th and October 30th to date. The SDO HMI colorized magnetogram. It's magic. It uses polarized light to determine those magnetic fields. Anyway, let's go over volcanoes, and there's been ground uplift happening on Iceland. And this is more ground uplift than happened before the 2020 and 2022 eruptions. So there could be a major eruption about to happen there. So the seismic activity has been diminished over the past few days. However, again, larger uplift than occurred the last 2 times there were eruptions there at Iceland. So, possible new eruption about to happen there at Iceland. Klyuchevskoye is producing about a 10,000-foot plume of volcanic ash as extreme strombolian activity continues on Kamchatka. Suwanosejima also producing a 6,000-foot plume of volcanic ash. Please do not pole vault the caldera. Mount Mayon, unknown volcanic ash plume over the Philippines from it, 7,000-foot ash plume from Ibu. Krakatau might be fixing to erupt once again, as there is a bunch of seismic activity happening below it, as well as ground deformation there as well. So Krakatau looking like it might be about to erupt again. Magma motions and inflating ground. Semeru producing a 14,000-foot ash plume over East Java as it explodes. It's a flight level 140, flight level 070 over Dakono at Halmahera. Headed down to North America, Popocatépetl exploding, flight level 220. It's a 22,000-foot ash plume. Central America featuring Fuego in Guatemala at a 15,000-foot ash plume. 15,000-foot ash plume at Revenador in Ecuador. And in Peru, Sabancaya, producing a 22,000-foot plume of volcanic ash. It's a flight level 220. Next, looking at seismic activity. There are the past 90 days of seismic activity. And let's see what's been happening in the past 24 hours. We'll cite quakes of a 5 or greater magnitude. So, pretty light in the 5+ magnitude quakes. The first one that's happened in the past 24 hours, the oldest one, was at 8:09 this morning on October 30th, way down south in the South Atlantic there near the Southern Ocean. A 5.1 at the South Sandwich Islands region at 8:09. That might be the only 5+ magnitude quake. Nope, one more at Jamaica. Check it out. Largest quake in the Caribbean for a long time. That one likely did some damage. At 5.4 at Hope Bay, Jamaica. Doesn't look like a particularly populated region, but there is a town there. So yeah, 5.4 at Jamaica. That was at 15:57 Universal Time this afternoon. And those are the quakes of a 5 or greater magnitude. Let's get back to some more solar imagery here. From the Smash News Network, least busted name in news. Here's a fantastic 304 angstroms 24-hour video. You might see a CME kicking off right around this area. Looking like it's headed off to the west right there, like a laser beam. So that's another 24-hour video, and let's zoom out to show the full disk. That is the extreme ultraviolet emissions of ionized helium from the SDO. And let's take a look at some stats. What's going on with space weather? We expected some more space weather that didn't really show up. The 10.7 centimeter radio flux did go up, though, to 140 solar flux units. There is the 1-year graph. The black line is the 10.7 centimeter radio flux. The red line is the sunspot number, which should rise again in the coming 24 hours. NOAA still forecasting some geomagnetic storm conditions tonight, so the possibility of a mild geomagnetic storm could be tonight. It could be a little bit stronger than that, too. Don't be surprised to see a KP6, as we have not seen the second coronal hole high-speed stream, and we are expecting one from that sunspot, from that coronal hole that's now in the western limb. So, yeah, I believe there is some high-speed solar wind on the way yet, folks. Sometimes they do arrive late, sometimes they arrive early. This one looking like it's on the late side. Next, the past 4 hours of Earth's magnetic moment from space. We do still have a heightened solar wind. We do have some density, too, so this one has some teeth. This is the past 4 hours of magnetohydrodynamic pressure to about 12 Earth diameters. You will see some variations happening there in the model as a result of varying parameters. Here's Earth's magnetic moment from the ground. Again, significant variation happening here. And we'll show you why in a couple of frames. So that's the past 4 hours of magnetic flux density from the ground level. Nanotesla are the units. Geospace delta B would be the changes to Earth's B field. KP index currently at 2.33, and it's been a lot calmer than expected. We expected a geomagnetic storm last night. It hasn't arrived yet. Don't be surprised if it does, basically at any moment. So next, looking at the ACE solar wind data, and I'm just going to move on because there's so much missing data here. The last 7 hours or so are not there. So here's the Discover looking a lot better, and it's showing us two different signals in the density. So check it out. We have this low density signal at about 1 proton per cubic centimeter, and then we have this higher density signal at about 10 protons per cubic centimeter. So two different wind regimes there, likely being measured kind of at once. You can also see these two different signals in the temperature and also the velocity. So solar wind speed here did make it up to the high 500s, something like 570. Solar wind density made it up to about 14 protons per cubic centimeter. We are waiting for a second pulse of high-speed wind, and that could pretty much show up at any moment. Look to see this density drop off before it. So far, though, things have been quite mild. Current conditions are about 12.5 protons per cubic centimeter for the solar wind density. Solar wind velocity here having dipped in the past half hour or so, now 518 kilometers per second. GOES magnetometers here fairly smooth, smoother than expected. We expected some geomagnetic storm conditions. So far, not showing up. Next, our top view ecliptic plane field plot, and Earth is just in the process of crossing a sector boundary as we create the video. So perfect timing there for the sector boundary crossing. Look at that Earth's magnetic field line right here on the edge of North Pole magnetism, about to snap into South Pole magnetism. So that's what's going on. Let's play that again. That's pretty sweet. So South Pole current sheet, probably already here. Keep in mind this data is over an hour old when we created the video. I'll say it. Welcome to the South Pole current sheet. And here's our line of sight field plot. Here the sun's B field is depicted in blue, polar fields in green for north and red for south, and the photosphere magnetism in grayscale. That's the gong magnetogram. We'll also show the line of sight ecliptic plane field plot. And we still do have magnetic indecision happening around the eastern limb. So at the moment, South Pole magnetism is winning, and we'll show that next with our line of sight coronal hole plot. So here you can see these North Pole coronal holes rotating to the west, South Pole coronal holes rotating in from the east. And let's take a look at coronal holes from SDO. So right now, this is the way it's working out. These are north, and these are south. So that's the current scenario. Another 24-hour video from SDO. And here's a close-up of that very well-defined coronal hole. And as it rotates toward the west, you should be able to see more depth in the solar corona, as it is very bumpy. So you'll see that looking like it's closing, but it's not necessarily really closing. It's just being obscured by the large plasma filaments that are now making their way in between the Earth and the closest star. So that brings us to sunspots. And sunspot number is just below 80 now, 79 or so sunspots, according to Royal Observatory of Belgium. Here's our flare probability and scoreboard, and the most likely place to see a large flare, statistically speaking, is from 3474. However, there may be a likelihood of flares showing up on the limb as well. So don't be surprised to see a solar flare up here at the northeast or in the southeast. But the most likely place, because of magnetic shear characteristics, is sunspot 3474. And let's look at sunspots from SDO, 94 angstroms plus the SDO continuum. The 94 angstroms highlights the active regions. The continuum shows sunspots. So these are 24-hour videos. Once again, you'll see the growth of quite a few sunspots there. So growth happening in both the northern and southern hemispheres as a couple more active regions rise. Now we've moved the Earth scale off the edge for the magnetogram, so you can see how mixed the magnetism is over there. It's very gray. It's just indecisive. So again, there is magnetic cancellation happening over there in the east, as the sun tries to decide the polarity. We'll be watching. And let's move to energetic particles and solar flares. So the first thing is SEPs. Those are pretty important. They cause polar radio blackouts. And we do have a heightened possibility of solar energetic particle events at the moment. None so far. But the forecast is looking better if you are a solar proton event enthusiast. Fasten your safety belts. We might very well see an SEP, a solar energetic particle event. Background X-ray flux is now getting back up to a C-class level. It's at about a B7 about a B8, I would say, at the moment. Flaring has been mild for the past 24 hours. Let's take a look at flares from SDO. There's the 94 angstroms wavelength. Again, the most likely place to see a large solar flare is down here. And there still is a possibility of one up here or down here in the southeast. But the most likely place is that sunspot that's right in the Earth-facing portion of the solar disk as we produce this video. So that's pretty sweet, and let's chill and take a look at what's going on overhead. So here is the sky over Lehigh Valley, Pennsylvania. That is where we're located, by the way. And if you're new to the channel, drop us a line and let us know where you're located. If you're viewing the soon after sunset sky, you might be able to see Mars. It's pretty close to the horizon, but if you've got low horizon, low light pollution, you might be able to see Mars. Less likely to see Mercury, Saturn up there, high on the ecliptic. That is what the sunset sky looks like there as the sun is touching down at the horizon as we create the video. Next, solar system forecast. Here's where things are today. Here's where things will be tomorrow on All Hallows Eve. Hopefully your soul is protected against... Hopefully you've got a rubber raft or a gold piece to get onto Charon's boat before thy soul is cast into the river Styx. That's where things will be in a week on November 5th. So, yeah. That's where things will be on November 6th. We will have a crescent waning moon by the 6th of November. And I think I might have forgotten something. It's the astronomy photo of the day, the Cepheus flare molecular cloud. Yeah, it's a bunch of rich molecular dust and gas. Spooky looking ghosts that look like something out of a Scooby-Doo show. So that's apod.nasa.gov's Reflections of the Ghost Nebula. Located in the constellation Cepheus, obviously. apod.nasa.gov is the location to check that out if you like. I have vanished and then I have reappeared. Now, let's talk CMEs. So here are yesterday's CMEs. That stands for coronal mass ejections, by the way. Those are not earthly directed. Today, we may have one that is. Very early in the morning, almost first thing. We do have a halo. So, if that is an earthly directed coronal mass ejection, we can expect that to arrive sometime late in the day on November 2nd. We're going to do further analysis here in just a moment to determine if that is indeed an earthly directed CME, as there is a halo there. It's a little on the stealthy side. Just first thing this morning, and then unfortunately a lot of missing data there, so I'm not so sure that that's earthly directed, but let's take a look at some more data here to see if we can figure that out. So there is a bit of a halo-like eruption there. We're going to let these play all the way through. We've got the C2 on the left slightly ahead of the C3 on the right. So here comes first thing. And there indeed you can see some ejecta coming out of both the top, the northern portion, and the southwestern portion. We're going to look a little bit closer to see if that's a far side coronal mass ejection or an Earth side. Because if it is an Earth side one, it will be headed almost directly toward Earth. Fingers crossed for that. First we'll show stereo A. Let's see what's going on at stereo A. It's located where this red circle is. It's a location of stereo A, and here are the coronagraphs. So again, late last night into early today. We do see ejecta coming out of the north and the southwest. Do we see it on the raw coronagraph? Let's see. Yep, there is a partial halo there. I'm suspecting this is on the far side, but let's take a look at our custom coronagraphs to see if we can get a better idea. Here we've got SDO 193 angstroms, along with the limited data from the Soho-Lasco C2 and C3. Let's zoom in a little bit closer to see if we see any plasma motions first thing this morning. I don't think so. Here we've zoomed in and got rid of C3 and we've added 304 angstroms. So yeah, I don't think that's earthly directed. I think that's on the far side of the sun. Here is just 304 plus 193 angstroms as we transition to filaments. And there are still a whopping, there's a heaping helping of filaments right now on the closest star, on the Earth-facing portion of it. So we could see several of these turn into coronal mass ejections. Some of them are kind of pointed right toward Earth. You can see one right there in center disk. It's anchored just north of that most active sunspot. So the likelihood of coronal mass ejections for the next 24 hours is just this side of 100%. So very high likelihood. And let's move to filaments. Here is the hydrogen alpha imagery from Big Bear. So look at all those dark absorption features there. Massive filaments. Some of those already have names. Some of those could get names. I don't know. If you want to name them, join us over on Twitter. Follow the hashtag #NameThatFilament. If you're on social media and you want to follow us, that's the place to do it. Twitter. That is where the most interaction occurs. Although, consumer tip, the censorship is still pathetic. So we wouldn't be surprised or offended at all if you unplugged entirely from social media, because it is truly putrid. We must use these things for business purposes. So what can I say? We're on Twitter. And you can see some prominences there rising in the east around where those active regions are set to make their way over the eastern solar limb. And before we get to bonus features, let's take a look at the GOES 16 SUVI. There's ionized helium from the GOES 16. And certainly this area right here is the place to watch for big flares. Anyway, here come bonus features, starting with satellite charging hazards. And right now we've only got minimal charging hazards over India, the northern Indian Ocean, the Bay of Bengal, and so on. Moving toward the Middle East, some minor surface charging hazards there for satellites. Nothing to be concerned about. Not that you own satellites anyway, you probably don't. Next, it goes electron flux over the past 3 days, and we're expecting a significant electron storm here following the subsiding of these coronal hole high-speed streams. You can see both the satellites there making their way into warning levels there. That's the GOES 16 and GOES 18's radiographic measurements from their near geosynchronous equatorial orbits. They use radiography to measure the F-flare for free electrons. Next, the 1-year graph, and you can see a big uptick there in the electron flux. We're expecting another uptick, or at least NOAA is, and I tend to agree. So there's the forecast, and expecting a pretty strong electron storm here in the coming day or two. So now keep in mind that might be a little bit delayed because the coronal hole high-speed stream is delayed. Or maybe it'll miss entirely because of Earth moving to a new current sheet. Who knows? As again, we've just crossed the sector boundary crossing, so that can affect things too. Next, the layer where it's measured, the F-flare. Feel free to pause the video in this frame if you're not familiar with atmospheric temperatures, electromagnetic radiation penetration, and chemical concentration. So here is the F-flare in vibrational frequency, and we are seeing extended periods of low-frequency anomalies. Don't worry if that's Greek to you. We will show the anomalygram as well. So it looks like it is returning to a more high-frequency state here. Keep in mind, again, we are expecting another significant coronal hole high-speed stream pulse, so that should create a lot more low-frequency anomalies. Here's the anomalygram depicting anomaly in megahertz from a 30-day median. So you can still see quite a bit of red on here, and we expect even more red on here to show up from that next coronal hole high-speed stream pulse. And it could last for quite a while, so it could last for most of the day tomorrow. Don't be surprised if it does. Here are the latest images of the ionosphere, courtesy of Australian Government Bureau of Meteorology. There's 2145 Universal Time ionogram and 2145 Universal Time anomalygram. Next, the whole atmosphere model. It's for GPS and radio operators especially. showing the total electron content and anomaly and maximum usable frequency and anomaly. And next we're going to show just the total electron content. So here's the diagram. Electron content TEC, or total electron content, is depicting all of the free electrons from about this level down to ground level. A run of about 12,500 miles to where your GPS satellite is located. And here is the total electron content forecast. Which still frankly looks erroneously. I don't know what's up with it. But the electron content anomaly over North America looks like it is legit. So here it's going to depict the anomaly from the 10-day average, high electron count anomalies in red, and low electron count anomalies in blue. Free electrons from 12,500 miles or so down to ground level is what you're seeing there. And we'll close out space weather, as we do, with the latest colorized magnetogram and SDO continuum imagery. So that right there is a beta gamma class sunspot group. It isn't really beta gamma delta class. No, it is beta gamma delta class because of this group, this sunspot right here. That makes it beta gamma delta class, just barely. So, yep. Significant likelihood of large solar flares from that group. Let's take a look at these others as well. We'll do this group also. That is a beta gamma class. In fact, that one's actually beta gamma delta class as well. Again, just barely. I'm going to say beta gamma class. So this might be a new sunspot group up here as well. That one could get a name. And then we've got this group. That group is beta gamma class, since there's no north-south line separating all of the fields. But it's not beta gamma delta class. It's just beta gamma class. As far as these new groups that may be rising over the east, that doesn't look like a sunspot yet. And it's too early to tell down here, so no new sunspots yet, but it looks like continued growth over the past 24 hours. And let's get to meteorology. So we're going to start out by looking at mean sea level pressure. And there is a mean low pressure system that's been dropping lots of snow and lots of precipitation across the U.S. It's sitting up right off the coast of Nova Scotia right now. And, yeah, there it is. That's the low that's been causing so much precipitation across the U.S., now making its way out into the North Atlantic. That is the mean sea level pressure and surface winds. These are the surface winds of the east. Shout out to our viewers from under, and who would be visible if we had high magnification on this map. Here are your jet streams for the east side. Here are your jet streams for the central world. Jet streams, now surface winds of the central world. Surface winds of the west. And there are the jet streams, the 250 hectopascal winds of planet Earth. Next, the visible satellite for the Americas. Love making these videos around sunset, as these are just spectacular images from the NASA GOES Interactive Weather Satellite Suite. And let's take a closer look at the Great Lakes region as weather is making its way across them. We centered the map around Toledo, Ohio for this. Great view there of Superior, Michigan, Huron, Erie, and Ontario. Next, precipitation type, and you can see most of the snow here is now only in the most northern most portions of the U.S. Most of the rest of that is either rain or wet snow. And check it out, quite a bit of snow here has been laid down. That is the snow depth. And that is mostly subsiding at this point. Here's our weather.gov map, and look at all the cold weather warnings. Hard freezes over a huge portion of the U.S. Freeze warnings there. If your location is lit, click your location. Those are too many counties for us to cover. What do you say? What do we say? Press the like button. Oh, you're so... Well, you get the idea. Next, some forecasts. Here's the GFS 72-hour pressure and precipitation forecast. As heavy weather is about to show up once again in the Pacific Northwest. Another pulse of extreme rains. Look at that. And more snow coming down the Great Lakes pipeline. So there you go. That's a 72-hour GFS pressure and precipitation forecast. Next, the GFS 72-hour temperature anomaly forecast, as most of the country here is under cold temperature anomalies for the next 3 days. Keep in mind that is in degrees Celsius, as high temperature anomalies in the Carolinas turn to low temperature anomalies promptly, and they stick around for a couple of days. Last but not least, what's in control of all of that is the jet stream. There it is, the 250 millibar winds. As cold Canadian air makes its way down and a second pulse behind it. So big dips in the jet stream are bringing big dips in the thermometer. Let's take a look at lightning. There is some really outdated lightning data. We're going to bypass that and look at a real-time lightning map from lightningmaps.org, powered by blitzertung.org. And that is where the lightning is striking at the moment. Some Caribbean lightning, some Central Mediterranean lightning. About 168 strikes per minute. We're going to close this mother out with Doppler, satellite, and water vapor for the lower 48. So there's that precipitation spreading all the way from Monterey, Mexico to New Brunswick. That's New Brunswick, Canada, not New Brunswick, Jersey. Here is visible satellite. It's an atmospheric creek. And there is the water vapor map. You can see that band of moisture there, sandwiched in between two relative high pressures. So this dry mass of air is, relatively speaking, high pressure. This is, relatively speaking, high pressure. And this is, relatively speaking, low pressure. Yeah, moist air. It's less massive than dry air because H2O weighs less than nitrogen. Because it's N2. N2, it's more massive than H2O. I know it might seem counterintuitive, right? All that water, you think it's heavy? Well, plain old air is heavier than all that moisture. So those are facts. That's why the pressure is high on a clear day and low on a rainy day, folks. So that was radar. Here's visible satellite. And last but not least is the water vapor map. That should clear things up if your Doppler is unclear. Hopefully we were clear about space. Coming at you from here, the Smash News Network, least busted name in news. We'll be back again tomorrow. In the meantime, may that solar wind be at your back, and may thy soul not be cast into an ever-deepening and darkening abyss of doom, destruction, and delusion, because you failed to press the like button. Since I'm scared for your soul because you failed to press the like button, I'm going back to the bunker. I'm going back to the bunker again. Has encouraged me to climb in.